So chapter 12b looks at solving linear equations. We've got two linear equations sitting here, and you can see that I've put it into matrix form like this. Now, we can do the matrix multiplication in a moment to prove that it all works out, but you can kind of see, just visually, you can see how this works. You can kind of see we've got 4x and 2y equals 5. So the coefficients, the numbers in our top equation are 4, 2, and 5. And if you look at the top row of all our matrices in this equation, we've got 4, 2, and 5. Then our bottom equation, our coefficients are 3, 2, and 2. And then in our bottom row, our numbers are 3, 2, and 2. An important thing to note is the order we've put them in as well. So if you look at this top row, we've got the coefficient for x, which is 4, so 4x, and then the coefficient for y, 2y. So it goes x and then y. Same thing on the bottom. It's our x coefficient, 3x, and then our y coefficient, y. So because we've gone x, y, x, y, from top to bottom, we need to make sure that the column matrix goes x, y. So it's all about just making sure we've got that order correct. Now, let's actually do this matrix multiplication and see how it's going to work out. So we've got this square matrix, 4, 2, 3, and 2, and it's multiplied by a column matrix xy. So we've got this matrix here. So in our first element here, we're going to have 4 multiplied by x, and then 2 multiplied by y. Then our second element down here will be 3x plus 2y. And noting up here, that is exactly the linear equations that we have. So we know that 4x plus 2y equals 5, because of these equations up here. And we know that 3x plus 2y equals 2. So actually doing this calculation shows us that yes, this matrix form is a good representation of these linear equations. So now that we know how to actually write the linear equations in matrix form, we also want to look at how to solve them. So when we're solving linear equations, this is where the inverse matrix does become very important. So using the example we had from before, let's let our matrix with all our coefficients equal A. The matrix that has the variables, the x and y, which we're trying to solve, we're going to name that x. And C is the column matrix that has the solutions in them, so 5 and 2. So when we put our linear equations into matrix form, it takes the form of AX plus C. So I'm going to write that down here. We've got, AX equals C. Now what I'm going to do here is I'm going to pre-multiply each side of this equation by the inverse of A. So remember, pre-multiply, the word pre means before. So I'm going to pre-multiply both sides by the inverse of A. Now, because I've done the same operations to both sides of the equal sign, I haven't really changed anything, so this is something we're allowed to do. It's just like multiplying each side by 5. You're not really changing anything. So what we want to notice is we've got inverse of A multiplied by A here. Now we should remember from the previous chapter that if you have the inverse of A and multiply it by itself, or if you go the other way around, if you have A multiplied by its inverse, it's the identity matrix. So that's actually the definition of the inverse. When you have A and you multiply it by its own inverse, you get the identity matrix. So I can replace inverse of A multiplied by A by just the identity matrix. So we've got IX equals inverse of A multiplied by C. Now what we also need to remember here is that when you multiply a matrix by the identity matrix, you just get that matrix by itself. So you can almost consider the identity matrix is kind of like multiplying something by 1. If you had 7 times 1, you just have 7, right? Multiplying by 1 doesn't change anything. Same as the identity matrix. So we have x is equal to the inverse of A multiplied by C. And that is what's going to get us our solution. Because remember, this X matrix is our X and Y. So the sort of problem-solving method that we just went through, these sort of steps, it's not something you need to remember. It's likely not something you're going to be asked about to actually perform these calculations, but it is important to see how we get there. What you do need to know that if you can write a set of linear simultaneous equations, if they can be written as AX equals C, then our solution X is equal to the inverse of A times C. Now, you may remember from the previous chapter, when we spoke about inverse matrices, you know that not every single matrix will have an inverse. Remember that if the determinant of a matrix equals 0, then the inverse actually does not exist. That leads us to believe that there's not always going to be solutions for linear equations, because if the inverse of A doesn't exist, then how can you have a solution? So we're going to look at when do simultaneous equations actually have a solution? And it is all to do with the determinant. So if the determinant of your A matrix does not equal 0, what that means is that the inverse of A does exist, and you will have a unique solution for your simultaneous equations. But if your determinant of A does equal 0, it means that the inverse does not exist. Therefore, there are no solutions for your simultaneous equations. Now let's do a couple of examples to show that we actually know how to apply this rule. So what we're going to do first is let's solve the following simultaneous equations. Our first step is to actually put it into matrix form. So we've got 3 equations and we've got 3 variables, x, y, and z. So we know it's going to be a 3 by 3 matrix. In fact, something I should actually point out is that it's always going to be a square matrix, because remember that only square matrices actually have an inverse. So for this to work, it needs to be a square matrix. If you have 3 variables, you need to have 3 equations. If you had 2 variables, you have to have 2 equations, 5 variables, 5 equations, and so on. So we know it's going to be a 3 by 3. So let's draw this out. Now we're just going to put in all the coefficients. So I'm going to make sure that column 1 is filled with all my x coefficients. So I've got 3, 4, and 1 as my x coefficients. Column 2, I'm going to fill up with my y coefficients. So we've got 4, -4, and -2. And in my third column, I'm going to fill it up with my z coefficients. Now you can notice that in the first equation, we actually don't have a z term here. So you can imagine that it's like we've got a plus 0 z, because obviously 0 times something equals 0. So you can imagine that the coefficient of z in this first equation is 0. So we've got 0, 1, and 6. All right, so that is our A matrix. Now we want to put it in the form of AX equals C. That's the form of the equation we want, A times X equals C. So our X matrix will be the matrix that has all the variables in it. Now, because we went X, Y, Z, we need to make sure we keep that order going for our X. So X, Y, Z. And equals, we just put all the solutions in. So 6, 12, and 22. Now we can just double check we've done that correctly. You want the first row of the sort of whole equation to sort of be all the coefficients of your first equation. So 3, 4, 0, and then 6, 3, 4, 0, and then 6. And then if you sort of, you can double check the other two and make sure we've got them all in the right order. So now we've written it in matrix form, in the form A times X equals C. Now, remembering back to our notes, if we have a set of simultaneous equations written as AX equals C, then X is equal to the inverse of A times C. That's what we're going to want to do. We've got X is equal to the inverse of A times C. Now that is a job for our calculator. Alright, so I've just filled out, I've assigned my A variable or my A matrix to the variable A. I've assigned my C matrix to the variable C, and I've just calculated A to the power of -1, which will give you the inverse matrix multiplied by C. And we've got this matrix here. So I'm going to round them to 3 significant figures. We've got X is equal to the matrix 2.10, -0.0759, and 3.29. So knowing that we had X assigned as X, Y, and Z, that's our X, that's our Y, and that's our Z. Example number 2. Let's start by getting it into matrix form. So 1, 2, 2, and 4, which is what we've got here. I've gone X in column 1, Y in column 2, so XY. So we go XY, and it equals 4 and 6. Now that is in the form of AX equals C right now, so that's good. So we know that X is going to be equal to the inverse of A multiplied by C. Again, that is a job for the calculator. Now we get something funny when we try to put this in. When I've assigned my A and my C and worked out inverse of A times C, I've got undefined. Now, what that tells me is that the determinant of A must be 0. So let's actually double check that. Yep. So because the determinant of A is 0, that means that the inverse of A does not exist. So when the calculator tried to work out the inverse of A times C, the inverse of A, it just doesn't exist. Therefore, there are no solutions for these sets of equations. There is no solutions. And finally, we'll look at an example. So this is from the 2017 exam 2, and essentially it's the same calculation we've just been doing, but it's in a bit of a more worded question, so it might seem more complicated when you first look at it, but it's really not. So we've got a school canteen that sells pies, rolls, and sandwiches, and the number of each that's sold in 3 weeks is shown in this matrix. So we got pies, rolls, and sandwiches, and the amounts sold in week 1, week 2, week 3. So considering this matrix equation below, we want to find out what is the cost of a pie, which is A, the cost of a roll, which is B, and the cost of a sandwich, which is C. So it's already given it to you in matrix form. So it's actually one step less. So it's already given it to you in the form of AX equals C. So knowing what we already know, we know we can solve for this matrix X as the inverse of A times C. And that's all we need to do in our calculator. We've assigned M to this matrix. We've also assigned C. And then we've worked out the inverse of M times C, and it's given us these values here. Now, because these are costs, they are dollar amounts. So when we write our answer, we've got the cost of a pie is $4.65, $4.20 for a cost of a roll, and $3.80 for a cost of a sandwich.